Hello everyone. In this lecture, we'll be solving some past paper questions of coordinate geometry taken from IGCSE and O levels. Okay, so let's start. In the very first question, it's about a line L joins point F3, 2 and G minus 5, 4. We have to calculate the length of line L. So whenever we have to find the length, we always use the distance formula. So if the distance formula is to be used, it is distance is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. We have the coordinates here as x2, x1 we can take as minus 5 and 3. It would be minus 5 minus 3 whole square. And y2 minus y1, it would be 4 minus 2 whole square. Simplifying it further, minus 5 minus 3, that's a minus 8. Minus 8 whole square, that's a 64. And 4 minus 2, that's a 2. 2 is a square, that's a 4. We get the final answer as, in the third form, it would be under root 68. So if the question says you have to give the answer in the third form, that would be under root 68. Otherwise, it would be 8.25, correct to 3 significant figures in decimals. 8.25 units. Moving onwards, in part B, we have to find equation of perpendicular bisector of line L. Of line L. That means we have a perpendicular bisector which is on the line L. Now we know that to find the perpendicular bisector, we just need to know two things. First, the midpoint of the 2 points given and their gradient. So these 2 points F and G, if these are the 2 points, okay, so we have the 2 points as G minus 5 and 4. Wait. Okay, so we have the point G as minus 5, 4 and F as 3, 2. And we have to find the perpendicular bisector. So perpendicular bisector of this line L would be passing through the midpoint first thing and make an angle of 90 degrees. So this is a perpendicular bisector whose equation is to be found. The perpendicular bisector. The very first thing to be done is we have to find the midpoint of these 2 points F and G. So midpoint. Midpoint, it would be x comma y is equals to x1 plus x2 upon 2, y1 plus y2 upon 2. So for these 2 points, x1 plus x2 upon 2, it would be minus 5 plus 3 upon 2 and 4 plus 2 upon 2 it would be. So minus 5 plus 3, that means it would be minus 2 upon 2 and minus 2 upon 2, that would be a minus 1. 4 plus 2, that's a 6. 6 upon 2, that's a 3. We've got the midpoint as minus 1 comma 3. So when I say midpoint, it's a point, this point, which is minus 1 comma 3. And this point is also a part of perpendicular bisector. So if it's a part of perpendicular bisector, that means we would be using this point -1, 3 to find the equation of perpendicular bisector. Next thing we need to know is the gradient of this line L. So for gradient, we have the formula as y2 minus y1 upon x2 minus x1. So y2 minus y1, in this case, it would be 2 minus 4 upon 3 plus 5. So 2 minus 4, that's a -2. 3 plus 5, that's an 8. So we get the gradient as -1 upon 4. And for the perpendicular bisector, gradient of the perpendicular bisector, since we know that it's a perpendicular, so gradient has to be negative reciprocal. So it would be +4. We have the point, we have the gradient. So we'll use this gradient and point to find the equation of perpendicular bisector. We use the formula y is equal to mx plus c now. And we'll first find c. It would be y. We'll use this point -1 and 3. We have the two things known, -1, 3, the point on the line, and 4, the gradient of the line. It would be 3 is equals to 4 into -1 plus c. 3 plus 4 is equals to c. So we get c as 7. Finally, equation to be found, it would be y is equals to mx plus c. And it would be y is equals to gradient as 4. So 4x plus 7. So y is equals to 4x plus 7 is the equation of perpendicular bisector of line L. Moving onwards, part C, it says a point H lies on the y-axis. Now this is one important thing, lies on y-axis. Such that the distance GH is 13 units. GH is 13 units, the distance. Find the coordinates of the two possible positions of H. So two possible positions. Now, to understand this question, I will draw a rough sketch. It's a rough sketch. Please keep this in mind. It's not to be scared. So technically what happens is when a line or any given curve cuts a y-axis, its x-coordinate is always 0. We have to use this condition where when the x-axis is 0. To G, we know that G is having the coordinates as -5 and 4. So -5 and 4, so -5 and 4 would be somewhere here. Okay, this would be -5, this would be 4. So G -5 and 4 is somewhere here. Okay, so point H is somewhere there on the y-axis. So now there are two possible positions. The two possible positions are this point H. It can be above the point G. It can be somewhere here. Or it can be below the point G. It can be somewhere here. And for both these possible positions, the x-coordinate would be a definite 0. Y-coordinate we don't know, so we are supposing it a C. So it's 0, C for both these possible positions. Why two possible positions? Because either it's above or below. The distance, the length, it's 13 units. So either it's above or it's below. As per the given condition, the length has to be 13 units. So these are the two possible places where we can have the age. And either it's above or below The length is 13 here. So either it can be a 13 here or it can be a 13 here. So since it's a distance given, so we'll start with the distance formula. And distance formula, we know that it's under root x2 minus x1 whole square plus y2 minus y1 whole square. Distance is already given, which is 13. So 13 is equals to under root x2 minus x1. It would be uh, this point 0 comma c. We'll suppose this as x2 comma y, right? And this is x1 y1. Okay, so x2 minus x1, it would be 0 minus of minus 5, that would be a plus 5. 0 plus 5 whole square. And y2 minus y1, it would be c minus 4 whole square. Simplifying it further, we'll get this as 13 is equals to 0 plus 5, that's a 5. 5 is square, that's a 25. So 25 plus c minus 4 whole square. And now we have this square root to get rid of. So to finish a square root, we'll square both sides. On squaring both sides, 13 square would be a 169. And square on the square root would cancel the root, and that would give us 25 plus c minus 4 whole square. Now some addition subtractions are to be done here. It would be 169 minus 25 is equals to c minus 4 whole square. 169 minus 25, that's a 144. And now to finish the square, we'll square root. So c minus 4 whole square is equals to 144 it was. So to finish the square, we square root. So this square would be cancelling the root, giving us c minus 4 only. And square root of positive 144, that would be a plus minus 12. So the two possible values for c here, it would be c is equals to positive 12, positive 4, and that would give us 12 plus 4 as a 16. So one possible value is 16. Second possible value is c is equals to minus 12 plus 4. Minus 12 plus 4, that's a minus 8. We get this as minus 8. And the x coordinate, we know that it's a 0. So these are the two possible positions or two possible points for H. Let's move on. We have this another question in line. Now it says AB aligned with midpoint M. A is 0.2, 3 and M is the 0.12, 7. We have to find the coordinates of B. Coordinates of B, that means we have been given with the midpoint and one of the endpoint, and we are supposed to find the second endpoint. Just to understand this situation, we'll draw a rough sketch. So we have been given with the point A, which is 2, 3. And then there is another point B, which is the endpoint, and we don't know what is this point. M, the midpoint is given, which is 12 and 7. So midpoint is given here, and one of the endpoints is to be found. So we'll suppose the coordinates for B as, let's say, we are supposing this as P, Q. P, Q, the coordinates representing B is something what we need to find here. So we'll start with the midpoint formula. And the midpoint formula is x comma y is equal to x1 plus x2 upon 2 comma y1 plus y2 upon 2. It would be 2 plus p upon 2, 3 plus q upon 2, and the midpoint is given as 12 comma 7. So as per the rule of equal order pair or equal coordinates, we'll compare the x coordinate with the x coordinate and y coordinate with the y coordinate, giving us two different equations to be solved. So the first equation to be solved would be 12 is equals to 2 plus p upon 2. 2 into 12, that's a 24, is equals to 2 plus p, and we get p as 22. And then 7 is equals to 3 plus q upon 2. 7 2s are 14 is equals to 3 plus q. Subtracting 3 from q, that would give us q as 14 minus 3, which is an 11. So p comma q, the coordinates are 22 comma 11. It's not necessary midpoint will only be helping us, midpoint formula will only be helping us in finding the midpoint. Midpoint formula can also help us in finding one of the two endpoints. Part B, we have to show that the equation of the perpendicular bisector of AB is 2y plus 5x is equal to 74. So we already have found, we have been already given as the midpoint for AB, which is 12,7. So for perpendicular bisector, we know we need to know the midpoint and the gradient. We already have the midpoint, which is 12,7. So now we'll find the gradient first. So gradient of AB. M is equals to y2 minus y1. So y2 minus y1, we have got the point B as 12, 22 comma 11. Okay, using the gradient formula, we'll have the gradient as y2 minus y1, which would be 11 minus 3 upon x2 minus x1, which would be 22 minus 2. So we get the gradient as 11 minus 3, that's an 8, 22 minus 2, that's a 20. Simplified form, we'll get this as 4 2s are 8, 4 5s are 20. We get gradient as 2 upon 5. And for perpendicular bisector, the gradient, it would be negative reciprocal, so that would be minus 5 upon 2. So we have the gradient, we have the point, which is the midpoint, which is 12,7. So using the gradient and the point, we'll now find the value of C using y is equal to mx plus C. In place of y, the y coordinates are 7. Gradient, that is minus 5 upon 2. X coordinate, that's a 12 and a plus C. 2 1s are 2, 2 2 6 are 12. 6 into minus 5, that would be a minus 30. So 7 is equals to minus 30 plus C. And we get C as 7 plus 30, which is a 37. And to find the equation, y is equal to mx plus c, we'll use the formula again. So y is equal to gradient, that is minus 5 upon 2x plus 37. So this is the equation of perpendicular bisector, but the required form is something where we cannot see the fraction. So to finish the fraction, we have to take LCM and then cross multiply. So taking the LCM, we'll get this as 2 minus 5x, and 2 plus 2 into 37, that's a 74. Cross multiplying, we get 2y is equals to minus 5x plus 74, and we are just one step away. We just need to move minus 5x on the left side. So that would give us 2y plus 5x is equal to 74. So we have got the required equation. The required equation 2y plus 5x is equal to 74 to be proved. Let's move on. Part C, it says the perpendicular bisector of AB passes through the point N. The point has coordinates 2, n. Find the value of n. So we know that if a point lies on a line, we can always substitute the coordinates of the point in the line. So we have this line as 2y plus 5x is equal to 74. And this 2, n, this is a part of this line. So we can always substitute the coordinates in the equation of the line. So in place of y coordinate, it's an n, so 2n plus. In place of x coordinate, we have a 2, so 2n plus 5 into 2 is equal to 74. We'll have this as 2n plus 10 is equal to 74. 2n is equal to 74 minus 10, that's a 64. And n is equal to 64 upon 2, which is a 32. So we get n as 32 here. Moving onwards, we have to find the area of the triangle here. Now, area of triangle in case of coordinate geometry, always remember, whenever you have to find the area of triangle, there are two possibilities. And the two possibilities are about the base side. Either the base side, it is parallel to the y-axis, or it is parallel to the x-axis. If I have to show you by drawing a rough sketch. Okay, so either the base side is parallel either to the y-axis or the x-axis. So either the base side is parallel to either the x-axis. So when it's parallel to the x-axis, this would be the base for us. And this gap would be the height for us. When it's parallel to the x-axis. And when it's parallel to the y-axis, we would be having a triangle somewhat like this. In this case, base side would be this, which is the difference of the y coordinates, and height would be this. And that is the difference of the x coordinates. So for the first case, when the line is parallel to the x-axis, you can see the y coordinate is constant because it's a horizontal line. And when the line is parallel to y-axis, so y-axis parallel, that means it's a vertical line. For vertical line, it's the x coordinate which is constant. Okay. Now let's first write down all these points A, M, and N. A was having the coordinates 2, 3. B was having the coordinates 12, 11. Sorry, we don't need B, we need M. M is having the coordinates 12, 7. And N, it's having the coordinates 2, 32. This is point N for us. So either it would be the x coordinates common for the 2 points or the y coordinates common. So here we can see we have the x coordinates common for the 2 points. A and both have the x coordinates common, which is 2. So that means this is the case where we have the base parallel to the y-axis. Base parallel to the y-axis. So somewhat like this, you'd have the triangle. You have one point as 2, 3. So this is A. 2, 3. This is N. 2, 32. And this is point M, which is 12, 7. It's a rough sketch, so you don't need to scale it. Now the base and the height. So base and the height. Base would be the difference of the y coordinates. Difference of the y coordinates, it's 32 minus 3. So 32 minus 3, that is a 29. And height, that would be the difference of the x coordinates. The difference of the x coordinates here. We have the x coordinates for these 2 points as 12 and 2. We have the x coordinate is 12 and x coordinate is 2. So 12 minus 2, that's a 10. Now we'll use the area formula. Area is equal to half into base into height. Area we have to find half, base it's 29, height that's a 10. The 2 ones are 2, 2 5s are 10, and 5 times 29, that is 145. So this is how we find the area of the triangle when the 3 points are given. And keep this thing in mind that out of the 3 points, 2 points definitely would be having either the x coordinate same or the y coordinate same. It's a must thing. Related to such case, I have picked up one more question where we have where we have to find the area. And this time what I've done is I have kept the y coordinate same. So if I have to draw the rough sketch here, so we have the first point as O 0, 0. A 5, 0, so A would be somewhere here. and B is 7 comma 8. So 7 comma 8 would be somewhere here. Okay, so we have taken the axis as 2, 4, 6, 8. So that means here in this case, the triangle we have is OAB is the triangle and its area is to be found. So base for us, it would be this gap, the difference of the x coordinate, and height for us, it would be this gap. So base would be difference of the x coordinates here. So 5 minus 0, that's a 5. And height for us would be the difference of the y coordinates. And difference of the y coordinates, it's 8 minus 0, which is an 8. So area, that would be, we were only doing part 3 because part 1 and 2 are regular parts. Part 3 was a bit different. So area, that is half into base into height. Half, base is 5 units, height is 8 units, so 2 ones are 2, 2 fours are 8. And we get the area as 4 5s are 20 square units. This is how we find the area when we have a side, when we have the base side parallel to the x-axis. Unlike the previous example where the base side was parallel to the y-axis. Moving onwards, we have this one more question. And in this question, it starts with finding the gradient of line J. Now to find the gradient, we need any 2 points of the line. So let's pick up this first point as 0, 1, and the second point, it would be 10, 6. Now with these 2 points known, we can easily find the gradient of line J. The first part, we have to find gradient of J, that would be y2 minus y1 upon x2 minus x1. So 6 minus 1 upon 10 minus 0. So 6 minus 1, that's a 5 upon 10. We get the gradient as 1 upon 2. So gradient of line J, that's 1 upon 2. Second part, we have to find the equation of line K. The equation of line K, we can clearly see that it's a horizontal line. And whenever we have horizontal line, the equation of line is always y is equals to constant, and y is equals to constant. The constant is always the constant y coordinate. Constant y coordinate. And for this whole line, we can see it's the y coordinate 1, which is constant throughout. I mean, if you look at this point, this is 8, 1. Maybe this point, this is 4, 1. So y coordinate is constant throughout the line. So we have the equation here for this horizontal line as y is equals to 1. Moving onwards. In the third part, we have to draw a line passing through 6, 1 such that area enclosed between J, K, and L. So they're talking about the enclosed area. Enclosed area is 6, and then this also needs to be passed through 6 comma 1. So we have to satisfy these three conditions. It has to be enclosed. First thing, that means it has to be a bounded region between the three lines. We already have the two lines J and K, and we need to draw this line, the third line L, such that the area we have, the enclosed area or the bounded area we have is 6 centimeters square. And this line L is also passing through the point 6 comma 1. So one point we have this is as 6 comma 1. And since it's the bounded region, so the second point it's this. This is 0 comma 1. We already have the 2 points about this this line, this enclosed area between J, K, and L. Now, here in this case, we can see that the base side to be taken would be the horizontal line. Why? Because we can see it's this line K, which is parallel to the x-axis. And whenever it's parallel to the x-axis, whenever a side is parallel to the x-axis, that side would be taken as the base side. So we have this side as the base side. And for this base side, base, we know that it's the difference of the x coordinates. The difference of x coordinate is 6 minus 0. The base we have 6 minus 0 as a 6. We have got the base side. So if we may use the area of triangle formula, area is equal to half into base into height. Area is already given, that is 6. Base we have already figured out, which is also a 6. And the height is something what we don't know about this triangle. If we may solve this, we'll get this as cross multiply. We'll get this as 2 6 are 12 upon 6 is equal to height. 6 1 are 6, 6 2 are 12, and we get height as 2 units. So 2 units means from the base, height has to be 2 units above. So height has to be this much from the base. This has to be the height. So since it has to be the enclosed region, the boundary region, so we will go in line of this. This is where the second point of the line should be. So our required line, the third line L, this should be passing through the point 4 comma 3. So the required line L that starts from 6 comma 1 and it passes through this point. It passes through this point 4 comma 3. And this is the line L we were supposed to draw. Part 4, it says we have to find the equation of line L. So to find the equation, we need to know, we have to use the formula y is equal to mx plus c. And from the graph, we can clearly see the y-intercept, it's a 7 for this line L. So we only need to find the gradient here. So gradient, we'll pick 2 points, 6 comma 1 and 4 comma 3. So 6 comma 1 and 4 comma 3, it would be 3 minus 1 upon 4 minus 6. To 3 minus 1, that's a 2. 4 minus 6, that's a minus 2. We get the gradient as minus 1. Using y is equal to mx plus c, we have the equation as y is equal to minus x, and the y-intercept is 7. So y is equal to minus x plus 7 is the equation of the required line L. Part 5. Line N. So now it's a different line. They are talking about line N. Line N is perpendicular to line J. First thing. Add 2, 2. Find the coordinates of the point where line L crosses the y-axis. So crosses the y-axis. What we need to do is we first need to find the gradient of this line N. Now, about this line N, this is perpendicular to J at 2, 2. Perpendicular to J at 2, 2. So 2, 2, we have this here. And it's a perpendicular line on J. So perpendicular line on J means we have already found the gradient of line J in the first part. This is the gradient we have found. So since the line N is perpendicular to J, the gradient has to be negative reciprocal. For the line J, the gradient was 1/2. So that means for the line N, the gradient would be negative reciprocal, and which would be -2. Okay, what the gradient? Now it says the line N crosses the y-axis. So for y-axis, we know that x coordinate is always 0. So x coordinate is always 0. Y coordinate we don't know, so we are supposing a variable c for it. So 0, c. So that means about this line N, what information we have is we have the gradient. We have one of the points which is 2, 2. And the second point about this line, because it passes the y-axis, so we have suppose the point as 0, c. So that means we just need to find this c here, the only missing y coordinate. So we'll use the gradient formula here only, which is y2 minus y1 upon x2 minus x1. In place of gradient, we'll use the gradient of line N, which is -2, is equals to, for y2 minus y1, it would be c minus 2. And for x2 minus x1, it would be 0 minus 2. Now this would give us -2 is equals to c minus 2 upon -2. Cross multiplication, we'll get this as -2 into -2, that's a -4, is equals to c minus 2. So c minus 2 is equals to -4, and we get c as -4 plus 2, and c it's a -2 for us. So this point where the line crosses the y-axis, this point we suppose as 0, c, it's basically the point 0, -2. So this is it. This was all about solving a few important and different nature of past paper questions of coordinate geometry. Hope you have understood all the concepts well. Thanks for watching.